We're continuing with multiplying and dividing polynomials for Chapter 7. This is our second lesson where we're going to look at dividing monomials. Before we get into dividing monomials, I do want to do a quick review from Lesson 1, just these first three examples. So I would like you to freeze your video and try these first three examples for yourself, and then check and see what my solutions are. So there are the solutions for those three. Double check that you have the correct solution. When I am checking your work tomorrow, I am going to be looking for your process. So if you've just written down those three answers, if you could add in a bit more work other than just your solution, so I know where it came from and I know that you just didn't copy them off the video, so you know what you're doing. Okay, so getting into dividing monomials. So again, we only have monomials, so there's only single terms, and they're going to be divided. And so I still want us thinking of two different methods. So the first method is using tiles, and again, we're using the area model. Okay. And so what this says is model the numerator. So the numerator, reminder, is the top of your fraction as the area of a rectangle. It's important that we line them up as rectangles, and we only line up side lengths that are the same together. Remember when we had the ones, we figured out that the ones, you can't line up ones next to an x, they never match up exactly. So make sure that you're only lining up ones with ones and x's with x's. That's important. And then the second thing it says is arrange the tiles in such a way so that one side matches the denominator. So we have 1x, we have 2x, that's the denominator, and then negative x squared, negative x squared, negative x squared. So the area is negative 4x squared, and the tiles have been arranged so that one of the sides is 2x. So in order to solve this division, we need to find out what the other side length is. So we have a length of x and a length of x. Now, we have to think of our sign rules a little bit, and so if we have negative divided by a positive, we are going to get negative and negative. So negative 4x squared divided by 2x is negative 2x. Looking at the second one, there's a little bit of a typo there. Oh no, we're good. So we have an area of 6x. This is our area. Okay, 6 x's. And we need one of the side lengths to be 2x. So here's our side length of 2x. And so we need to find the other side length. Okay, so this side length is 1 and 1 and 1. So this side length has a length of 3. So 6x divided by 2x just gives us 3 ones. There's no more variable. Okay, so we're going to do these ones this exact same method. So start with the area of 8x squared, and we need to make a length that is 4x. So 1, 2, 3, 4. So this is my length of 4x. I need to arrange the 8x squared tiles so that it fills that length of 4x. So 1x squared, 2x squared, 3x squared, 4x squared, 5, 6, 7, 8x squared. So now I'm looking for the other side length, and we have a length of 2x. So 8x squared divided by 4x gives us a length of 2x. Okay, and the way we could double check is go the other way. 4x times 2x, so 4 times 2 times x, 8 x squared. So it works. Okay, looking at the second one, we need to have an area of negative 10x squared. And we need one of the side lengths to be 5x, so we'll go this way this time. So 1, 2, 3, 4, 5. Remember, if we're making rectangles, it doesn't matter which side you pick. So we need to make negative 10x squared. So there's 1x squared, and I'm just going to put a negative sign inside it to show that it's negative. So there's 5 negative x's, x squareds, pardon me. There's 10 negative x squareds. And if we look at the side length, we have a length of 2x. And if we have positive, a negative divided by a positive will give us a negative. So the other length is negative 2x. And again, if we wanted to double check, we could go 5x times negative 2x. And 5 times negative 2 is negative 10. And x times x is x squared. So negative 10x squared. And that's what we started with. So we're good. Okay. Again, we can do it numerically, numbers with numbers, variables with variables. So we can rewrite this as negative 18 times x squared over 6 times x, like that. Okay? So all I've done is I've just kind of taken out part of the fraction line. Okay, so we're thinking numbers with numbers, variables with variables. So now we can see that we have negative 18 divided by 6. Okay, so if we solve this, we have negative divided by positive, which is going to give us negative. 18 divided by 6 gives us negative 3. X squared divided by x to the power of 1. Keep in mind, you can either do cross-out method, so you could have x times x. Right, we can do cross-out method, or we can use our exponent laws and think x to the power of 2, take away 1, so we get negative 3x to the power of 1, so just negative 3x. Okay, looking at the second one. 9 times x times y over 3x, or 3 times x. So we're thinking numbers with numbers, letters with letters. So 9 over 3 is a fraction. X over x as a fraction. And I actually like to split up the letters as well. Times y over, well, there is no y on the bottom, so we'll just put a 1. Okay, now we can divide. So 9 divided by 3, that gives us a 3. X divided by x will cancel out. And we're left with y divided by 1, that just gives us y. So 3 times y. Okay, looking at our next examples, I'm going to do the exact same thing. So 15 times a squared times b squared, 3ab. So we're putting the like terms together so that way we can simplify them. So again, 15 divided by 3 gives us 5. A squared divided by a to the 1 gives us a to the 1. B squared divided by b to the 1 gives us b to the 1 left. Looking at the next one, I actually want to change the example on this one because I want you to just notice something. So I'm going to make this an r to the 4 on the bottom. Okay? And so now when we split it up, 72 times q times r squared over 9. There is no q in the denominator, so I'm just going to put a 1. And r squared over r to the 4. So 72 divided by 9 gives us 8. Q divided by 1, we get left with 1q. And r squared divided by r to the power of 4. There are more r's on the bottom, or in the denominator, so we're actually going to get left with r's in the bottom. And so if we're thinking cross-out method, this is r times r, 1, 2, 3, 4. We get left with 2 r's in the bottom. Okay, so it could look like that, or we might say 8 cubed over r squared. Okay, so just keep in mind your examples could look like that. You're not always going to be left with more of your variable in your numerator. Just going to have to erase this. Looking at our next example. Again, there's no y in the denominator, so we're just going to write a 1. We get left with 8x y squared. Okay, I'm going to let you try F and G and H on your own. We will check those together tomorrow, but I will do the next example with you. Okay, and so in this next example, we've given you a rectangle, and we've said this is what the area is, and this is what one of the side lengths is, and we want to know what's the other side length. So we'll call this the base. So just starting with our formula, area equals base times height. If we're looking for the base, we're going to take the area and divide it by the height. So to find the base, we're going to take the area, 32 meters squared, divided by 4 meters. Now I know we've talked about this a little bit already, about the units and how do the units cancel. But now, hopefully, you kind of notice that how they cancel. So separating it into numbers with numbers and variables with variables, we end up with 8 meters. Okay, or 8m. So units, exponents on units work the same way as exponents on variables. So as we move from area to length or to volume, you should be noticing the exponents on your measurements change just like they would on variables.